Hello students, let us continue with the exercise of the lesson Electrochemistry. Question number 3, answer the following in brief. First question, explain the effect of dilution of solution on conductivity. Answer, molar conductivity of electrolytes increases with the dilution, that is with a decrease in concentration. Molar conductivity is the conductance of all ions produced from 1 mole of electrolyte. As solution is diluted, total number of current carrying ions increases due to increase in degree of dissociation. This increases the molar conductivity. Second question, what is salt bridge? Salt bridge is an inverted U-shaped glass tube filled with either KCl or KNO3 or NH4NO3 in 5% agar-agar gel. It is prepared by filling a glass tube with a hot saturated solution of salt and agar-agar gel and allowed to cool. The cooled mixture becomes solid so that it never drains out of the inverted tube. Third question, write electrode reaction for the electrolysis of aqueous NaCl. The cell consists of a container filled with aqueous NaCl in which two neutral graphite electrodes are immersed. Two electrodes are connected to a source of electricity, that is battery. The electrode connected to positive terminal or battery acts as anode and the other one connected to negative terminal acts as cathode. Reduction half reaction takes place at the cathode. At cathode, two reduction reactions complete. One is the reduction of Na plus ions as in the case of molten NaCl. That is Na plus plus E minus gives Na. The other reaction is reduction of water to hydrogen gas. That is 2H2O plus 2E minus gives H2 plus 2OH minus. The standard potential that the reduction of water is higher than that of reduction of Na plus. Hence, reduction of water is the cathode reaction when aqueous NaCl is electrolyzed. Oxidation half reaction at anode. 2Cl minus gives Cl2 plus 2 electrons and 2H2O gives O2 plus 4H plus 2E minus. The standard electrode potential for the oxidation of water is greater than that of Cl minus ion, or water has greater tendency to undergo oxidation. It is therefore expected that anode half reaction would be oxidation of water. But the experiments have shown the gas produced at anode is chlorine and not oxygen. This suggests that the anode reaction is oxidation of Cl minus to Cl2 gas. Therefore, we have to consider the oxidation half reaction as 2Cl minus gives Cl2 plus 2 electrons and reduction reaction is 2H2O gives H2 plus 2OH minus. The overall cell reaction is 2Cl minus plus 2H2O gives Cl2 plus H2 plus H2 plus 2OH minus. The results of electrolysis of aqueous NaCl is hydrogen gas is liberated at cathode and chlorine gas is liberated at anode. Because Na plus ions remains unreacted and OH minus ions are formed at cathode, NaCl solution is converted to NaOH solution. Question number 6. Using the relationship between delta G0 of cell reaction and standard potential associated with it, how will you show that electrode potential is an intensive property? Answer, we know delta G0 is equal to minus NF E0 cell, where delta G0 is extensive property as its value depends on the amount of substance. And E0 cell, that is the standard cell potential, is an intensive property. If the stoichiometric equation of redox reaction is multiplied by 2, that is the amount of substance oxidized or reduced are doubled, delta G0 doubles. The moles of electron transferred also doubles. The ratio E0 cell is equal to minus delta G0 upon NF will become E0 cell is equal to 2 delta G0 upon 2NF, which is equal to minus delta G0 upon NF. Thus, E0 cell remains same by multiplying the redox reaction by 2. Hence, electrical potential is an intensive property. Next question. Derive the relationship between Standard cell potential and equilibrium constant of cell reaction. Answer. The relation between standard Gibbs energy change of cell reaction and standard cell potential is minus delta G0 is equal to NF-E0 cell. The relation between standard Gibbs energy change of chemical reaction and its equilibrium constant is given as delta G0 is equal to minus RT ln K. Comparing the equation 1 and 2, minus NF-E0 cell is equal to minus RT ln K, or E0 cell is equal to RT upon NF ln K. Converting ln to logarithm to base 10, we can write E0 cell is equal to 2.303 RT upon NF logarithm to the base 10 K, or E0 cell is equal to 0.0592 upon N logarithm to the base 10 K at 25 degree Celsius. Ninth question. It is impossible to measure the potential of a single electrode. Comment. Answer. It is impossible to measure the potential of a single electrode because the half cell containing single electrode cannot exist independently as charge cannot flow on its own in a single electrode. The process of oxidation or reduction cannot take place alone. 10th question. Why do the cell potential of lead accumulators decrease when it generates electricity? How the cell potential can be increased? This topic, lead accumulator, is omitted. So let us move to the next question. Write the electrode reactions and net cell reaction in nickel-cadmium battery. Answer. Nickel-cadmium cell is a secondary dry cell. Anode of nickel-cadmium storage cell is cadmium metal. The cathode is nickel oxide, NiO2, supported on nickel. The electrode reactions and overall reactions are as follows. That is, oxidation reaction at the anode, Cd plus 2OH minus gives CdOH twice plus 2 electron. And the reduction reaction at the cathode is NiO2 plus 2H2O plus 2 electrons gives NiOH twice plus 2OH minus. And the overall cell reaction is Cd plus NiO2 plus 2H2O gives CdOH twice plus NiOH twice. Question number 4. Answer the following. First one. What is Kohlrausch's law of independent migration of ions? How is it useful in obtaining molar conductivity at a zero concentration of a weak electrolyte? Explain with an example. Answer. The Kohlrausch's law states that at infinite dilution, each ion migrates independently of its co-ion and makes its own contribution to the total molar conductivity of an electrolyte, irrespective of nature of other ion with which it is associated. Application of Kohlrausch's law. Molar conductivity of any electrolyte at a zero concentration can be calculated using Kohlrausch's law. However, it is particularly valuable to calculate lambda 0 of weak electrolyte. Lambda 0 value of strong electrolytes can be calculated by extrapolation method. From these values of lambda 0 of weak electrolyte can be calculated. Example, calculation of lambda 0 of acetic acid from lambda 0 values of strong electrolytes HCl, sodium acetate, CH3COO, Na and NaCl, sodium chloride can be done as follows. Lambda 0 means molar conductivity at infinite dilution. So lambda 0 CH3COH is equal to lambda 0 of HCl plus lambda 0 of sodium acetate minus lambda 0 of NaCl, which can be written as lambda 0 of H plus lambda 0 of Cl minus plus lambda 0 of CH3CO minus plus lambda 0 of Na plus minus lambda 0 of Cl minus plus lambda 0 of Na plus, which is equal to lambda 0 of H plus lambda 0 of CH3CO minus. Remaining terms Cl minus and Cl minus got cancelled and Na plus and Na plus got cancelled. So what is remaining is lambda 0 of H plus lambda 0 of CH3CO minus. That is equal to lambda 0 of acetic acid. Question number 4, second one. Explain electrolysis of molten NaCl. Answer. First, let us see the construction of cell. The electrolyte cell consists of a container in which fused NaCl is placed. Two graphite electrodes are immersed in it. They are connected by metallic wires to a source of direct current, that is battery. The carbon electrode connected to the terminal electrode of the battery is anode, and that connected to negative terminal of the battery is cathode. The reaction occurring in the cell. Fused NaCl contains Na plus and Cl minus ions which are freely mobile. When potential is applied, cathode attracts Na plus ions and anode attracts Cl minus ions. So oxidation takes place at anode. That is 2 Cl minus gives Cl gas plus Cl gas plus 2 electrons. And the second step, this 2 chlorine gas, that is Cl plus Cl forms Cl2 gas. So the overall oxidation reaction is 2 Cl minus gives Cl2 plus 2 Cl minus. Reduction occurs at the cathode. Each Na plus ion that reaches cathode accepts an electron from cathode and reduces to metallic sodium. That is Na plus E minus gives Na. The net cell reaction is 2 Cl minus gives Cl2 plus 2 electron, that is the oxidation half reaction. 2 Na plus 2 electrons gives 2 Na, that is a reduction half reaction. Therefore, overall cell reaction is 2 Na plus 2 Cl minus gives 2 Na plus Cl2. Results of electrolysis of molten sodium chloride. Number 1. A pale green chlorine gas is liberated at the anode. Number 2. A molten silvery white sodium is formed at the cathode. Eighth question. How will you calculate the number of moles of electrons actually passed and mass of the substance produced during electrolysis of a salt solution using reaction stoichiometry? This question is having two parts. First, we have to find out number of moles of electron passed, and second, mass of the substance produced during electrolysis. So the first part, number of moles of electrons passed. The charge of one electron is equal to 1.6022 into 10 raised to minus 19 coulombs. Therefore, charge of Avogadro's number of electrons will be 1.6022 into 10 raised to minus 19 multiplied by Avogadro number, that is 6.022 into 10 raised to 23, which is equal to 96,473 coulombs per mole, which is approximately taken as 96,500 coulombs, that is 1 Faraday. Hence, number of moles of electrons passed is equal to Q upon 96,500. Second part, mass of substance produced during electrolysis. Mass of substance deposited is directly proportional to the quantity of electricity passed through the electrolytic solution. So, mass of product formed is equal to number of moles of product multiplied by molar mass of the product. The balanced stoichiometric reaction indicates the number of moles of electrons used and moles of product formed. From this data, actual number of moles of product formed can be calculated as follows. Number of moles of product formed is equal to number of moles of electrons passed multiplied by mole ratio, where mole ratio is equal to moles of product formed in half reaction upon moles of electrons required in half reaction. Now, according to Faraday's first law of electrolysis, moles of substance produced is equal to I into T, that is Q upon 96,500 into mole ratio from stoichiometry, and the mass of substance produced is equal to I into T upon 96,500 into mole ratio into molar mass of the substance. The questions 9, 10 and 11 are from the omitted topics. Let us go for 12th question. Identify oxidizing agents and arrange them in order of increasing strength under standard state condition. The standard potentials are given. Answer. As the standard reduction potential, that is E0 reduction, increases, oxidizing power increases. Hence, the order of increasing strength of oxidizing agent is as follows. Al less than Al3 plus, less than Fe, less than Cd2 plus, less than I2, less than Br minus, less than Cl2. The last question, Which of the following species are reducing agents? Arrange them in the order of increasing strength under standard state condition. The standard potentials are given in parentheses. Answer. As the standard reduction potential, that is E0 reduction, decreases, reducing power increases. Hence, the increasing order of reducing agents are as follows. Br2 less than Ce3 plus less than Ag plus less than Ni less than Ti2 plus less than Mg less than K. So students, we have completed the lesson electrochemistry. Read the textbook and study well. Thank you.